Welcome to another tutor short provided by the Educational Support Services Department of Lehigh Carbon Community College in Snexville, Pennsylvania, which is just outside of Allentown. These videos review key learnings for the science courses provided here at L-Tri-C. And please remember that the Educational Support Services Department does provide walk-in tutoring 5 days a week. This video is an introduction to aromatic compounds. Now, compounds containing benzene have fragrant odors, and hence they were called or are called aromatic compounds. So that's where the name aromatic came from. Benzene itself is a unique compound. It is a 6-carbon cyclical structure with alternating double and single bonds. So if you look down here, you have your 6-carbon structure in a circle, the cyclic structure. And you notice you have these alternating double bonds. Every other carbon-carbon bond is a double bond. But you can draw that two different ways, as I show here. There's two different ways. And actually what's happening with benzene is it never stays in any one shape or one form here. These bonds, basically, if you remember, bonds are electrons going back and forth. These electrons are actually freely running around the benzene molecule. And so they call this resonance, but these electrons never stop moving. They're circling around here. And in any 1 second, you have one of these two structures present, but then the next second, you've got the next one. So they're constantly moving electrons. So the way chemists will represent benzene is this skeletal structure here. They'll show that cyclical structure, and they'll draw a circle in the middle, which gives you the hint that those double bonds in there are constantly moving. The electrons are flying around in this structure. So this is what you'll see in your textbook most of the time representing benzene. Now, there are also 3 substituted benzene compounds or aromatic compounds that have unique names. Over history, they developed these names and they have stuck to this day. And so if you have your benzene ring again here, and you have just a methyl group coming off the benzene ring by itself, they recognize that, or that is recognized as toluene. And a proper name more would be methylbenzene, because it's benzene with a methyl substituent. But as I said, commonly this is called toluene. Same thing down here. If your benzene ring has an OH group on it, a hydroxyl, then the common name is phenol, and that's what you'll come across. Official name may be more hydroxybenzene. But as I said, well-established name phenol. And same thing if you have an amino group on it, NH2 here, then that is called aniline, which is an aminobenzene. So you will come across these 3 substituted aromatic compounds, and these names, common names here, take precedent when you're naming the compounds, and I'll show you that on the next slide. So this final slide talks about how do you name aromatic compounds, and by now you've gone through namings on alkanes and alkenes, alkynes, other organic compounds. On the aromatics, what's unique about the ruling there is if you do have one of the common substituted aromatics, which I just said, toluene, phenol, or aniline, then one unique rule here is the carbon on which the substituent is attached will always be given carbon number 1 as a numbering. And then other than that, you basically are just following your normal rules for naming. So let's use this first one on the left here as an example. You have your benzene ring, and there's 1 chlorine attached to it. So you would call this, you could say 1-chlorobenzene. And as you remember, normally if there's just a 1, you don't need to use that. You can just call this chlorobenzene. And again, when we were numbering the carbons for this molecule here, since there's only 1 substituent on it, this will be carbon 1. You don't have to worry about in any way calling it 2 or anything. Now, if we have more than one chlorine, let's put a chlorine here now. Now we have 2 chlorines. Now we have to pick a chlorine, a number 1 carbon or a number 2 carbon. And again, here, if we pick this as number 1, then the next chlorine, if you go in this direction, it would be number 5. But if you go the short direction this way, this would be number 2. And you always go with the smallest numbering. So this would be a 1,2 dichloral, that's a D, dichlorobenzene on that. And if we didn't put it there, we put it over here. You should be able to see that that would have been a 1,3 dichlorobenzene. Or if we put it here, then it would have been a 1,4 dichlorobenzene. So again, not too unusual. You should be used to numbering and naming compounds that are in a cyclic structure. Only the difference here is you have benzene as your parent name. Now over here on the right, we have another benzene type structure. However, you should recognize with this CH3, this methyl group, that this is that common substituted aromatic of toluene. So you should recognize toluene or aniline or phenol. Once you recognize, oh, I have a toluene base here, now that's going to take precedent. Let me erase this so we can see it better. This is going to take precedent in the naming and the numbering. So now, because this will be carbon number 1, because that's the substituted carbon for toluene in this molecule. And then we're going to number from here. If we go counterclockwise, this chlorine gets to be number 3 and the bromine 4. But if we went this way, you should see this is going to be 4, but then the chlorine gets 5. And that increases the numbering, so we're not going to go in that direction. So we've identified chlorine is at 3rd position, bromine at 4th on this toluene. And remember, you're going to, when you write the name out, put them in alphabetical order. So bromine comes before chlorine. So this is going to be a 4 bromo 3 chloro toluene would be the name of this molecule. So I hope that gives you enough of an idea of the aromatic compounds, the simple ones, and naming of those compounds. Thank you.